No? Okay. Let's move on then. The next thing you have to do is now we're actually exploring radical equations. So pay attention to language. Language matters everywhere, especially in the math classroom, right? It can be a little unfamiliar. We just finished talking about, where's the title? The last lesson was called, here, radical functions. And now we're talking about radical equations. Do you know the difference? What's the difference between a function and an equation? Sorry, I heard lots of people talking. Johannes, what did you say? Doesn't a function have an equal sign too? Is this a function? Yeah, you solve an equation and you graph a function. So a function is in y equals form. A function is something that you put on a graph on the y and x axis. An equation is solving. And I've said this before and I'll keep saying it. Math has two, basically, two faces of this, like it's two faces of the same coin. If math is a coin, it's got like two sides to it. And they exist, they coexist, and they support each other, but they also do the same things. They function almost the same way. We've got a graphing approach to everything, and we've got an equation or algebra approach to everything. Graphing means you graph and you find solutions to your problems using a graph, making a graph up, or using a graphing calculator, or using Desmos. We can use graphing calculators and Desmos in our homework. We can't use them in an exam or a test though. So, solving a problem on a graph gives you the same answer as solving it with algebra. And in pre-cal, you're exposed to both of them all the time. So every little unit, this is our radical unit. So we talked about graphing things in order to solve problems. Now we're going to look at the equation part, which I think I took a poll before. I think most of you like the equation stuff better. That's more of a pre-cal thing. You like doing calculations and working through problems with pen and paper. So I think you're probably going to like today. Now, radical equation, just like a radical function, the definition of a radical function, anytime I hear the word, or you hear the word function, you think, oh, it's a y equals statement. That means I can make a table of values and I can graph it, or I can recall all my parent functions and do transformations. So, a radical function has a variable underneath the radical sign. Okay? A radical equation is going to look similar. A radical equation is something like this. Okay? It has a variable under the radical sign, but it's an equation that we can solve. Like I can't solve this. I can graph it to get a solution, but I can't solve this because there's two variables in it. I can solve this though, right? Because I've got, like you guys said, I have an equation with expressions or numbers on both sides. This I can solve, right? We solve this, we graph this, and the graph leads us to the solution, okay? So you all,
There's no one boundary.
that's right. This I can only put on a graph, but here, there's only one variable. You just do the math you have to do. How would I solve this equation? How do you solve variable or radical equations? Square root of sides, right? This is a really easy one, right? A baby equation, I would call it. So you guys know the procedure. Nothing's changed. I know you've done this before. So when I solve this equation, I just make sure my radical sign is on one side of the equation, isolated by itself, if I can do it. And then what I do is I square both sides. Because anything I do to one side of an equation, I have to do to the other. Why do I square? Why do I want to square both sides?
To disappear the square root.
To disappear the square root, right? To limit the square root. Because these guys are opposite. Squaring and square rooting undo each other. So guess what? It's back to basic. Whoa! I almost wrote with highlighter. What you learned way back probably in grade 7, you want to isolate x. And when you get x by himself, and he's all by himself on one side of the equation, and your other side is simplified, then you solve the equation because you know the identity of x. this is a true statement, right? That's your value for x, and that's because the square root of 16 equals 4, right? If I want to verify. So that's what we're doing today, something you've done before. We are solving radical equations. And I like this. I read through this last night. I should have assigned a page of reading for you, but maybe some of you did. But they have really good notes in this textbook for this particular section. I was impressed because it talks about really important things, like things that I have to say in class all the time. They have it in print. An equation like root of x plus 2 plus 3 is 5 is in which a variable appears. I would say it like in layman's terms, right? When a variable appears under the root sign, it's called a radical equation. They go through the same steps. To solve radical equations algebraically, right, pen and paper, we usually square both sides of the equation. This operation is true because two real numbers are equal. If two real numbers are equal, their squares are equal. Now this is important. The converse is not always true. That is, if the square of two real numbers is equal, the numbers are equal, and we'll see that in a moment. You always realize that when you graph a parabola, okay? Because what happens is, what they're saying is the square root of 9 is 3. If I squaring both sides of the equation, I get the square root of 9 squared is 9, the square root of 3 squared is 9, everything's true, but be careful, right? Because negative 3 and positive 3, they both equal 9, but they're not equal to each other, right? So that's just something to keep in the back of your mind. But basically, this is what I want you to focus on today. To solve radical equations, use the following steps. Isolate the radical. So before you do anything, make sure that the radical is isolated. For example, if I would have given you this, root of x minus 1 equals 3 and told you to solve it, your first step is isolate the radical, right? Move the 1 over. Now, the radical is isolated, then you square it, right? Because you have to square both sides. I don't want to square this whole side. This side would be easy. This side, I could do it, but it would lead to foiling out with the radical much harder. It's way easier to isolate the radical, okay? So we're going to isolate the radical. Once we've got him, if we have just one radical, it's super easy. Isolate him, square both sides, solve the resulting equation. Now, if you have more than one radical sign, those are the tougher ones, you might have to go through this process twice. Just like when we were long dividing polynomials, right? If we had a really high level polynomial, we would have to do it 2 or 3 times. Now, this is super important. Check to see if your solutions work. This is one of a few units where you must check your answers. It's called checking for extraneous roots. Does anyone remember that word? Okay, you must check all answers when solving radical equations. Okay, and the reason is this. Sometimes you can be led to a false root. Your answers appear to be equal, but when you actually do a check, you'll find out you had a false root hiding in there that you didn't know, because it kind of got lost in the shuffle of that squaring process. You kind of squared out a false root, and once you hit the squaring game, they both end up equaling, like in this case, 9, so it kind of looked like it worked, but when you actually go to check your work, the negative 3 wouldn't work in the question, only the 3 would work. Okay, so that's what we're going to do. Well, let's look at a couple of examples, and then in this textbook, and then I'm going to give you some, there's not many, but I'll give you just a couple of extra examples too. So solve and check root of x minus 1 minus 2 equals 0. Now algebraically, move the 2 over, right? Which is what we've done here. Square both sides. The only thing I don't like is they work across the page instead of down. Okay, so I'm just going to do it again, all right? So I got the square root of 1 equals 2. Square both sides because my radical is isolated. So I get x minus 1 equals 4. So x equals 5. Now, before I box this off and go on to my next question, we're going to double check to make sure we're going to verify. So what they've done down here is again, I don't like how they work, so I'm going to check in the original. The square root of 5 minus 1 minus 2, does that equal 0? Now, I don't think I've done any verifying in this class yet, so I'm going to show you how I verify. I actually put even a little pencil mark right down the equal sign, because when you're verifying is not solving. You're checking to make sure the left-hand side equals the right-hand side. So let's see if that works. What's the square root of 5 minus 1 is 4, right? What's the square root of 4? 2. 2 minus 2, 0. Because 0 equals 0, I have verified. Left-hand side equals right-hand side. Okay? That's what verifying is. It's not the same as solving. Okay, so now once I know that that works, I can box off my answer and it's a good one. If for some reason my left-hand side didn't equal my right-hand side, what's common practice is I wouldn't have boxed the 5, I would have slashed through it, and that tells me either 1 slash or big X, or you can write down extraneous. And you will see that there is going to be at least one or two of your questions that don't work, okay? All right, the other thing that we keep trying to tie back for you is to make sure that you're aware that every single equation can be solved one of two ways, algebraically or graphically. Just so you know, this is how we would solve an equation like this graphically. We would still isolate the radical sign. So I'd have one graph, y equals, so this is a graph of y equals root of x minus 1. And then on the right-hand side, because for an equation, you always have to think that you're given a left and a right, right? And the right hand of your equation is another statement, y equals 2. I'm trying to determine if the left-hand side ever equals the right-hand side. And if they do, where is that special value? So this is what happens. They've got it on a graphing calculator. I know a couple of you have it. I would enter both of these statements in, or I'd graph, if I was graphing manually, I'd graph my graph of, my radical graph, y equals root of x minus 1. And then I would graph y equals 2. And guess where they meet? They meet at x equals 5. Interesting, right? Now, I'm not going to call it decimals because it would take too. This isn't as nice as decimals, so I'm just going to show you. In a graphing calculator, right, which I know that you don't have, you can't use, but I'm just for instructional purposes. So what you would do is you would graph. And if you had nice grid paper, you could do this, right? But I'm not going to take the time right now and make you do that because it takes so much time. But here's my first graph is going to be the root of x minus 1, and we know what that looks like. The radical graph shifted to the right. And then this graph, what kind of graph is this? The graph of y equals 2. Just a horizontal line going through 2. This was my left-hand side of the equation. This is my right-hand side. I'm going to graph it. This is what we get. I don't know if it's better if I turn my light on or not. No, it's worse, right? Okay. So, and then what I'm looking for with graphing technology, I'm just seeing if they intersect. And if they intersect, there's a solution. So I use my graphing functions. What is wrong here? It's frozen on me. First curve, yes. I don't know what's happening, guys. First, okay, second calc, number 5, intersect. First curve, it's totally frozen on me. Jack, do you have your calculator here? Your graphing one, can I borrow yours? I don't know where. Yes, yes, it's totally frozen, it's not doing it for me. I don't know. Thank you. I'll just see if I can. Oh, good, you've got it in for me. Graph. Okay, I'm doing something wrong here. Okay, so his is working. Okay, let's try this one more time. So, graph, second calc, number 5. So, that's my first curve that I graphed. That's my second curve. And here's my intersection point. So what am I looking for? I'm looking for the x value, right? When I solve an equation, I'm looking for the x value. So this occurs when x equals 2, right? Again, I know many of you don't have graphing calculators, you don't need it, but you all have access to Desmos, either at home or on your phone or on the computers at school. So that clearly shows you x is 5. You've got 2 ways to solve this problem, using algebra, using a graph. What's your preferred way? Algebra. I say so, because look at the little, well, I was using technology, but even graphing this by hand, what do you need? You need good graph paper, right? You need good grid paper, you need a good pencil, you need to be able to graph. It takes a lot longer, right? And this focus for today's lesson, we're just going to do the algebra, right? The only advantage to graphing, how many people remember solving radical equations in grade 11 and maybe getting an extraneous root? Do you remember that? The only advantage about graphing, that means you get a false root, is it never leads you to extraneous roots. When you graph, like this question here, here is my 2 grids, root of x minus 1 and y equals 2, okay? This is root of x minus 1. Oh, it should say negative 2. And this is y equals negative 2, okay? Here's my first graph, y equals root of x minus 1. This is y equals negative 2. You know what my graph would show? No solution, right? So the graph tells you right away there's no solution. You know what would happen if I did it algebraically? I'd get solutions of x equals 5, okay? Then when I checked my answer, it would be false. There would be no real roots because the check wouldn't work. So that is one advantage of graphing. You'll always know if there's extraneous roots. Yeah? Okay, and then there's another one. Let's just try this one quick, and then there's one in the book. I'm just going to redo it on the right because at least they give us lots of room. So let's say I told for you to solve, or asked you to solve root of x minus 5 equals x minus 7. Okay? Now, first of all, this is more complicated, right? Because there's x's in a couple spots. So, is the radical isolated? Yeah, it's on one side of the equation. So what's my next step? Square both sides. Now be careful here with one of these guys. So here, squaring and square root undo each other, so I'm just left with x minus 5. On the right-hand side, x squared minus 14x plus 49. Agreed? All right, now what? Yeah. And what kind of equation do I have? Yeah. Now, quadratics, and this is why we spent a little time on reviewing factoring in this class. This is also why you spent so many hours factoring in grade 10, because your teacher told you factoring is important, factoring is important. The reason factoring is important is every single unit that we've studied so far and that we will study in this class will many times result in a quadratic equation. So even though we were studying radicals, guess what happens in a complex radical equation? It ends up being quadratic. Okay, so does this one factor? I've got x and x, factors of 54, what, 9 and 6? Okay, so I get x equals 9, x equals 6. If this was any other unit, maybe you would just be off to the races and on to the next question, but you have to check both of your answers. And checking or verifying means you're checking in the original question. Okay, so I'm going to check in this original format. So does 9 minus 5 plus 7, does that all equal 9? Okay, the square root of 4 plus 7 is 2 plus 7. That equals 9. So left-hand side equals right-hand side. Verified, right? So 9 is a good answer. I'm going to box it off. Let's check 6. Check x equals 6. So I've got the root of minus 5 plus 7. Does that equal 6? The square root of 1 plus 7. 8 does not equal 6. Left-hand side does not equal right-hand side. This is not a solution, it's extraneous, so I cross it out. Okay? All right, how many people remember radicals? Yeah? Are you guys? Okay, let's do these two really quick. I'm not going to bother graphing one of the graphs has already been done for you. Let's just go to your pink book. We'll do 2 more. Okay. This one has already been graphed for you. So on page 8, okay, go ahead, solve this one, check the answer. I didn't think it was possible. You guys are even quieter than normal. Give you a couple more examples too. Okay. I'm going to work on the I did all my attendance last night. I'll put all these in. Okay, so how do we do here? Did you move the 3 over? I think I would have done that. You can do it without moving the 3 over, it just makes it lots more difficult. Okay, then I square both sides. And I get x plus 5 equal to 9. X equal to 4. Oh, I did that prematurely, didn't I? Because I don't know, I gotta check. Does the root of 4 plus 5 minus 3, does that equal 0?
Yeah.
3 minus 3 equals 0. I got lucky there. Okay. Now, they're just linking, it says relating the roots and intercepts of radical functions. So relating the solutions to the x values of a graph. Now, let's see here. What do I have here? I have the graph of y equals x plus 5 minus 3. Okay, so here I would be graphing root of x plus 5 minus 3. And I'd also just be graphing the left-hand side of my function. Sorry, that's the left-hand side. That's my first statement. My second statement would just be y2 equals 0, I guess, right? So there are my two functions. Here's my first function, my y1. Here's my y2. Y equals 0. Where do they meet? 4. My solution is x equals 4. Well, this time the graphing was easy because the graph was done for us. We just had to find the answer. But normally you have to do the answer. So describe the relationship between the x-intercepts and the roots of the equation. They are the same value. Okay. So that's the concept I want you to remember, that you can do, again, reinforcing, you can solve the problem algebraically or graphically. You know what, I think I'm going to leave this one for now, for number 9. I think I'd rather just spend a little time. I want to give you, before I give you time to work on the radical equations and then hand your assignments back from yesterday, I want to just give you maybe a couple of tougher radical equations for examples, just so you're prepared, because I don't want you to, in the homework they're slightly tougher. So just more examples of radical equations, because it might have been a while since you guys had done these. So let's try an easy one to start with, easier. Okay. So x equals root of x plus 10 plus 2. Actually, maybe I'll put them all here. Let's try this one. Try that one. And then the very last example, I'll do this one. Probably the toughest one. Okay. So those are 3 radical equations. Solve for x, and that means checking for extraneous roots too, right? You can talk to each other in class too, right? Like, you don't have to be so quiet. Thank you. Thanks, Fran. If there's any questions, made notes, but I can
Joanna?
Joanna Bachman.
Who's Joanna?
Right there.
Oh, who wanted?
You want it, yeah.
Thank you.
Thanks, Joanna. Anyone got any questions or, is this kind of coming back to you? Radicals? Did you know what this is really? That little square is like the cloning symbol, right? X minus 7 square means x minus 7, x minus 7. Square, I have negative 7, negative 7, equal to 14x. So you're foiling out this binomial, right? That little 2 means you write it twice, and you foil out. It's multiplication by number, so you have to multiply the x by these 2. So you have 2 multiplications, and then multiply the 7 by these 2, so you have 4 terms. So this actually becomes x squared and minus 7x, minus 7x, and a positive 49. So then you get x squared minus 14x plus 49.
Instead of doing this one, I think this one it needs to get.
I think it'd be easier if you moved that over there.
Okay.
Yeah, much easier. Okay. don't forget, you're solving equations. You were given an equation, a left and a right, so you should always have a left and a right. Even if you end up moving everything over to one side of the equation and you end up in the solving section, it should still be an equation because it'll be equal to 0, right? I'll take a look at the first one. Everyone seems to have at least gone through the first one. So for the first one, what's the first step you would do with the first example? Move the 2 over, right? It's much easier to do that way. So I would get x minus 2 equals root of x plus 10. Anytime you can isolate your radical, you isolate. Now I can square both sides. Now I'm going to do this in my head because I think we're at that stage where you should be able to do it. So this really means, what does x minus 2 with a squared symbol really mean? It means that, right? It means x. It means the binomial. That square symbol means it's like cloning, right? You duplicate. So it's x minus 2, which gives me x squared minus 4x plus 4. And then here I just get x plus 10. I have a quadratic again. How do we solve quadratics? Everything to one side. So if I subtract another x, and I subtract a 10, this is what I'm talking about. I can't just leave this hanging. You can't turn an equation into just an expression. You always have to have a left and a right hand side. Okay? All right, this one factors, right? So I get x equals 6, x equals -1, agreed? All right, now I have to check, and I'm checking in the original form. So my check is, I'm going to do my check here. So 6 equals 6 plus 10 plus 2. That's going to be root of 16, right? Does 6 equal 4 plus 2? Yeah. So this is good. Radicals take longer than you think, right? Even if the radical itself isn't that hard, the checking takes time, but you must, because otherwise you could get some extraneous thing. I'm always leery of negative answers, but let's see what happens. -1 equals the root of -1 plus 10 plus 2. Uh-oh. We got it. Whoops. We got a problem here, right? -1 does not equal 5. That was extraneous. Now the reason you're getting extraneous roots is this process here, this squaring process, squaring opens the door to those extraneous roots, right? Because -3 squared equals 3 squared. Now, unfortunately, there's nothing we can do about that. If we want to solve this algebraically, the only way to get rid of those square roots is to square. But squaring introduces something a little dangerous. So that's why we have to check our answers. All right, I'm going to give you a few more minutes to fix or to finish 2 and... How many people were successful? Excellent. Okay, now try 2 and 3. If you're done really quickly, you can start working on the questions on page 112. But I'll go through these 2 examples as well. Okay, you want to talk about example 2? Okay, so this one's easy, nicely set up for me. All I have to do is square it, right? So when I do this, I have two binomials multiplied together. I'm going to get x squared minus 8x plus 16. And now the one with the radical, which kind of they always look harder. The terms with radicals looks harder when you first look at it, but once you have them isolated and you square, those are the ones that are easy to deal with, right? Because the square and the square root undo each other and you're just done. Okay, once again, we have another quadratic, x squared minus 7x plus 14, or sorry, plus 12. Okay, so factors of 12, x minus 3, x minus 4. So x is 3, x is 4. I'm just not sure about them yet. So I'm going to check. X is 3. And I had this conversation with Jack. You always have to check in the original, whatever you were given originally. So what I was given originally was the x minus 4. So 3 minus 4 equals the square root of minus 3 plus 4. Let's see if that works. Negative. I know it's not going to work right away. You know why? Does anyone know why I know for sure? Because I have a radical on this side. A radical is never going to be equal to a negative number, right? The square root of something's never negative. So that one doesn't work. All right, let's check x equals 4. So 4 minus 4, I'm going to get a 0 here, minus 4 plus 4. 0 equal the square root of 0. Yeah, 0 equals 0, right? That works. So I have one, and so far I've had one answer out of each set of answers that worked. And then the last one should be, it looks actually pretty straightforward. Just gonna I'm gonna double check on the latest. I'll be right back. I'm just gonna double check on the latest winning number and grab today's tickets. That's yesterday's winner. So today I will give you your tickets again. Okay, let's do the last example. Probably already done it. Were there any answers to the example 3? Was there a solution? Like this looks so ugly, right? The square root of minus 5x plus 26. It looks really yucky. But as soon as you square it, like it just becomes, okay, negative 5x plus 26. There's nothing easier than that. This one, okay, so I move my 5x over. That's a 3x and then minus 10. Okay, Johannes, what factors of 10 would give me negative 3? That'd be a minus 5, right? And a plus 2. So then I get, possibly, I get x is 5 or x is negative 2. So let's see. Does 5 equal the square root of minus 25 plus 26 plus 4? Does 5 equal the square root of 1 plus 4? Yeah, that works, right? Okay, so that one's good. This one doesn't work? Does it? Oh, sorry, thank you. Okay, so minus 2, does that equal? I don't think so. Negative 10 plus 26 plus 4. Does negative 2 equal? No. Negative 2 doesn't equal 8. Not at all. Okay, so that one's gone. I have one solution again. Okay? All right, so we've got lots of time left. Remember, this class doesn't end till 10 after 2, so you have a lot of time. 5 after, 10 after 2. So in that time, like I've mentioned before, it's built in. You have a work period, but you have a work period with an experienced math teacher, right, who teaches pre-cal, who can answer all your questions, whether it's on the topic of the day or old stuff or stuff that you might think is coming up or something that bugged you from the past. I'm going to get you to work on this, and again it says too, sometimes after checking for extraneous roots we find that none of our solutions work, right? And that might happen too. You might end up, after doing all this work, no solution. That just means there's no solution to that particular problem. But just remember to check. Now some of these are fairly easy, some not. If you're done, I would suggest a couple things. I mean, if you're done, you're done, that's it. But if you didn't hand back the radical functions assignment that I gave yesterday, please hand it in. I'll take a look at it. If you have any questions on that, please ask me. If there's any other question you might have, I think I might if I can get my act together, I think I might give you just an assignment to take home and work on over the weekend, right? Like these assignments, once again, aren't for marks, but you're all adult mature students, right? You know I'm not giving you the assignments because I like to mark on my nights and weekends. It's not really why I do it. It's so you can get feedback, and I've been really, really impressed and proud that you guys have been handing your assignments, And I've been trying to get them back timely, like really quickly, so that it makes sense to you. Like there's no point in me giving you an assignment and handing it back a week later because we're on to another topic. So my hope is that by giving you assignments and you don't have the pressure of having them worth marks either, you're doing it for your own learning, and I get them back quickly, that we can resolve any problems that you might have, right? And we can get all those issues dealt with before we move on. So if I can get my act together, I'm going to try and get an assignment so you guys can have something to look at on the weekend. A review maybe of everything we've done so far, something like that, okay? It might even be assignment with answers too, so you don't necessarily have to hand it in to me. You just come and see me if your answers don't match the assignment answers, right? But keep giving me feedback too. Let me know what works for you, if you like what I'm doing in class, or if you think there's something I'm missing that you might want me to do something a little different. I'm open to that too, right? Because ultimately we both want the same thing. We want you, I want you, and you